Anyway, welcome everybody to our next to the last, I think, research seminar for this semester. Everybody, we don't really need to introduce Professor Boarnet because I think you all know him. And he's the chair of the Department of Urban Planning and Spatial Analysis. And he and I do a lot of work together, and he is one of the most well-known people for knowing about land use and transportation. So with that, he's going to talk to us about dockless scooters today. And welcome everybody on Zoom. If you have any problems, hit the chat box. And we have somebody here watching the chat box. And those of us who are in person get to have lunch.
Yes. All right. Thank you. Welcome. Thank you. And yeah, for those of you on Zoom, Katrina will be watching the chat box. If you have questions, please type those into chat. I find that sometimes I don't see the chat function well while I'm speaking, but Katrina's watching me, and Katrina interrupt me if we have chat questions come up. And for those of you here, please feel free to ask questions at any time. We've got such a small group, I'll even ask your names so I can get to know folks. Why don't we start?
I'm Arno.
Arno?
I'm Leslie.
Leslie?
I'm Shen.
Oop.
Shen, or you can call me Nicole.
What?
Nicole.
Nicole, okay.
Yeah, I'm Catcher.
Okay, good. Welcome, welcome. Feel free to move closer down front if you wish. So, I did prepare the slides in a little bit of haste yesterday, and the title does have a typographical error in it. I meant it to say a land use model of dockless scooter travel. Now, in transportation, saying a land use mode of dockless scooter travel actually also makes sense. So I guess it could go either way. A land use model of dockless scooter travel. And this is work that is co-authored with two of our PhD students, Zachary Mallet and Clemens Pilgrim. So let me get started. And let me try to move this over maybe to this position. So our research objective was in some sense simple. What are the land use correlates of dockless trip generation? And so this is an old question. We've asked this about transportation certainly since the dawn of the automobile era. What are the land use correlates of travel generally and by mode? And so one idea is, well, this is a new mode. Could we understand dockless scooter travel by looking at land uses near trip origins and trip destinations and the way that we understand other travel? And I will tell you what I'm going to show you here only goes as far as looking at land uses near the trip origins. And so that's really the question. And the idea would be just to start that to see what we could learn. And so there weren't particularly strong hypotheses going in. One, you might imagine that there might be things you would expect, but I would frame this a little bit more as inductive work. You know, what are the land uses near places that have a lot of dockless scooter trips being generated, our trip origins? And then what insights would we get about dockless travel as a mode from that? I want to highlight two findings that we've learned so far. And this is work that was funded by the National Center for Sustainable Transportation. We have completed our final report. And so we are at that point. As you know, when you do these reports, when you've completed the final report, the work isn't really completed because you continue trying to understand things. So at this point in time, we've had two things that I'll get to at the end that I want to highlight. One is there's very striking weekday, weekend, and even hour of the day variation in dockless scooter travel. And that might be quite intuitive. That may not be surprising. I'll show you some information on that. What we find is that in a regression framework, if we look at block groups and the number of dockless trips that are generated within a block group, and if we develop, say, an interaction variable, dummy variable that says weekday or dummy variable for hour of the day, we find that the land use correlates, literally the interaction between weekday, weekend, or hour of day and the land use variables is usually statistically significant. So even the land use characteristics have an effect on dockless scooter travel that varies across type of day and across the time of day. Secondly, we explored something that in your econometrics classes, you were probably taught to never do. And that is to use the results of the regression to predict out of sample. Now, one thing to remember, sometimes on television, you'll watch those advertisements for automobiles, and the driver will be driving in a way that seems maybe even reckless or dangerous to show you the performance characteristics of the vehicle. And in very small print, the type will come on, trained driver, don't try this at home. So we thought that as a research team, maybe we could take a look at this with all the cautions that were necessary. The reason we explored out of sample prediction for dockless travel is that the data are only available in a handful of places. So to learn things about dockless travel, we are in a world right now where we might have to ask, what could we learn about California, say from Minneapolis? And we'll show you just an example of that. What could we learn about California from Minneapolis? And I think the answer is that there may indeed be some things. So those are the two key findings: weekday, weekend, time of day variation, and an exploration of out of sample prediction. Let me start with the data. I'll describe the data in two ways. What we hoped to do was to use two data sources for this research. The Los Angeles Department of Transportation developed what is called the Mobility Data Specification. And that is a data specification that they now use for dockless scooter providers within the city of Los Angeles. And dockless scooter providers are required by the city of Los Angeles to provide information on trip generations, trip attractions, literally from where trips start and end, the time of the trip start and end, and to do it in a way that the identity of an individual user would be concealed. So literally, one thing to remember about the dockless devices, they all have a GPS. So literally, when the device began to move, what was the GPS location, the time of day, when it stopped moving? What is the GPS location, the time of day, so that they could understand even paths, not only start and stop, but flows, not linked to any user account, and reported to the city in a way that could not identify any user. This mobility data specification has been adopted in many cities nationwide. Unfortunately, despite the fact that the city of Los Angeles developed it, they are at the present time not releasing the data to any other users, either outside of the city or in many cases within the city even, meaning other departments within the city due to privacy concerns. So this is something that, is a bit of a debate to be had in and of itself. Are the privacy concerns real concerns? Can the data be aggregated to the point where we have certainty that they are anonymized and that identities could not be revealed? The short answer is that whatever one thinks about whether or not user identities can be anonymized, and I actually think they can be, the city will not release the data. So we didn't get that data source. We were also hoping to work with a private dockless scooter company to obtain data. And the concern there was a little bit more idiosyncratic. Our key contact, right when the research was starting up, welcomed a new child into the family. That was right about the time the pandemic started. We went through several months with a combination of circumstances in the world and life events that we just weren't able to really move that data request forward. So we have since obtained data from that company for a later project. But the short answer is that what we found ourselves in is we found ourselves not able to get the data that we had hoped to get. So this leads to the next slide. Data, what we actually did. What we found that we had to do is we had to work with the cities that publicly reported dockless trip origin and destination data. And we looked quite carefully, and there are 3 cities, and as far as we can tell, only 3 cities that systematically report as a matter of public record on portals that are easily publicly available, scooter trip origin and destination data. Minneapolis will report scooter locations coded to the nearest street segment. So you can look at that. The scooters are identified by device number, and so you can figure out when a trip starts and ends by when a location scooter is in one location and then at a later time is in a different location. Louisville, Kentucky will report scooter locations coded to 3 decimal place GPS coordinates. And I'm actually forgetting the accuracy of 3 decimal places. If I recollect, it's in the tens of feet or yard, I think. It's fine enough that we could easily match those to the geography we used, which was census block groups. City of Austin reports scooter locations coded to census tracts, a higher level in geography than we were using. There's one other city that has been used in the literature also, and that's Washington, D.C. Washington, D.C. has not actually reported these through public portals, but the companies that operate scooters in Washington, D.C. have had their APIs be open enough that people can find and scrape scooter locations. We did not use Washington, D.C. because, as I recollect, that's for some of the providers, but not all. And there is also, let's phrase it this way. The cities I'm listing here are the cities that, as a matter through their own government effort, are making the information available. Washington, D.C., it looked like the API could be found for the companies. And we were a little unsure if that was quite the same as making the data available. There are articles in the literature that do use Washington, D.C. API data. Yes?
So was there a special interest or motivation to do this research for LA, or is this just as good?
Were there what?
Was there a special motivation to do this research with LA, or?
We had hoped. The original motivation was to do this with LA data in LA. Yeah, we couldn't get data in LA. Yeah, so that's when we went to the other cities. Does that answer your question?
Yeah, I was just wondering if this was considered just as good or is it second best to?
Well, towards the end of this lecture, what I'll show you is if we take the Minneapolis model and use it to predict dockless scooter generations in Los Angeles, what does it look like? Sadly, we cannot compare that to actual LA data. The LA data exists but cannot be accessed. Yeah. But I'll show you maps and talk you through what that would look like. We ended up using the Minneapolis and Louisville data because they allow matching to census block groups. We did not use Austin. So to get to your question, what we're doing now, and this is unusual, we're thinking we're in Los Angeles, we want to learn about dockless scooters. What can we learn from Minneapolis and Louisville? I think I misspoke earlier. So it's an unusual framing, but it's the nature of the data availability. And there are some interesting things that come up. So let me move to that. Let me start with just describing the data. What we're showing in the middle of the screen is a map of by block group dockless scooter trip generations. In Louisville, and by block group, dockless scooter trip generations in Minneapolis. And so what jumps out at you, these are a very downtown phenomenon. And in particular, we highlight where the University of Minnesota is in Minneapolis. There's really a cluster, two spatial clusters of dockless trip generations in Minneapolis, one in downtown and one near the University of Minnesota campus. The University of Louisville does have an identifiable cluster also, and downtown, which is kind of near a riverfront in Louisville, also has a cluster. The average trip count per day per block, the average, and that's a trip, think of it as a trip generation. In Louisville is 1.63 trips per day per block group on average. This is not a common phenomenon. In other words, your average block group in Louisville is generating less than 2 trips per day. Minneapolis, that's a larger number, about 8. The distribution is heavily censored at 0, and I'll show you some graphs in a minute. But ballpark in both of these cities, about half or more of the block groups generate 0 trips. And of course, in some of these cities, the dockless, or in some of these block groups, the dockless provider likely is not providing any service in block groups. The total number of trips that we have, 500,000 in Louisville, over 1 million in Minneapolis. And the span of the data for Louisville, ballpark, August to January of 2020, uninterrupted. For Minneapolis, summer of 2018 into November of 2018, skipping the winter months, and then May of 2019 into November of 2019. So from our API feed from the city of Minneapolis, it looks like they shut down dockless scooter trips during the winter, which given a Minneapolis winter seems logical. I have encountered some debate. I have encountered people who have said, oh no, I'm in Minneapolis, I take my scooter out in January, which sounds like a shockingly dangerous thing to do. I've also encountered people who have said, including members of our research team, who've said, I live in Minneapolis, I can promise you, they don't have scooters in January, which is consistent with the data. Probability distribution, average trips per day. The light is Minneapolis, the dark is Louisville, and in both cities you hit about 0 trips per day at around either slightly below or above the 50th percentile. So lots of censoring at 0, lots of activity in terms of trip generations from a very small number of census block groups. Dockless scooter trip lengths. There are a handful of outlier scooter trips that are more than 3.1 miles. Taking those out, dockless scooter trips under 3.1 miles or 5,000 meters peaks at just around a kilometer in both cities, and then the distance distribution drops rapidly. And I thought somewhere I actually had the mean. If I recall, the mean is ballpark around a mile. Or less, might be around 1,200 kilometers is ringing a bell. I don't know why I didn't put that in there for mean dockless trip length in both cities. So dockless trips are short typically. And then what I want to show you, and this is going to be I think maybe a little bit hard to see, but there's a strong time of day association with dockless trips. And what we're showing is over the time of day, from midnight to midnight. In January, this is Louisville. The horizontal lines show sun up and sundown in Louisville for January, the blue lines, and the yellow horizontal lines show sun up and sundown in July. So a winter and summer sunrise sunset comparison. And you see weekday, weekend. And what's striking is, first of all, a lot more dockless trips in the summertime than in the wintertime. So there's strong seasonality and a strong time of day effect. particularly striking in the summertime, less striking in the wintertime because there's fewer trips. But in the summertime, not long after sunrise, the number of trips per day begins to increase, continuing to increase into the afternoon. Dockless trips look like more of a late afternoon, early evening phenomenon. When the sun sets, looking at the yellow line and the yellow graph, dockless trips begin to reduce in frequency relatively rapidly. They appear to be a daylight phenomenon more than a nighttime phenomenon, and a summertime phenomenon more than a wintertime phenomenon. The weekday weekend, the only thing that really jumps out at this, the horizontal scale is the same, so more trips on the weekend than on the weekday. Minneapolis, all we have is July, same kind of thing, same time of day pattern, with less striking weekday variation. So yeah, but definitely a strong association with daylight. So I think this wraps up, descriptive statistics. I'm going to go into a regression analysis. Before I do that, any questions? Yes.
I guess this is not necessarily about that, but why do you think these two cities are actually open with their data this way?
Why do I think they're what?
Why do you think they're actually open with it?
You know, good question. And one we didn't ask because we were just so pleased to find any city that was open. So it's interesting. We didn't delve into it as much. Clemens, you scraped the data. Do we have any insights as to why these are the only places that appear to provide these in open data?
No, I can't really think of a good reasoning behind it. Minneapolis certainly has a good culture around being relatively open with most data sets. I don't know Louisville's culture well enough to really say anything about them.
Yeah, that would.
I know that Washington, D.C. had make your APIs public a condition for the operators to even operate in Washington, D.C. But there's some amount of random variation in what exactly the contract terms are that the operators have with the cities. And in Minneapolis and Louisville, that happen to be part of the deal. You can put scooters in our city if certain information about the trips is then made public at the end of it. But I could not explain to you why Minneapolis chose one way and say Chicago chose another.
Yeah. Except I would guess the tradition of open data probably is part of the story.
Thank you.
Yeah, okay. So the next thing we did, we matched the trips to block groups, and the dependent variable is trip count, the number of trips that originate in a block group, average per day. So we'll run the regression separately for Louisville and Minneapolis. And the independent variables will be measures of within the block group, job density, population density, and then densities of land uses drawn from OpenStreetMap. And so the land uses are really counts of number of identified land uses, which are often buildings in OpenStreetMap, classified in these ways, divided by land area. So density of establishments that are food, and on the right-hand side, you see the detailed classification of what we count as food. Density of establishments classified in OpenStreetMap as bar, club, nightclub, pub. Density of establishments classified as school, which was typically K through 12, not university. University would be the next thing. Density of establishments coded as university. Think of that as number of university buildings divided by the land area of your block group. So it's kind of density of university buildings in the block group. Density of places of worship, churches, religious institutions. And then a linear distance from the centroid of the, not census tract, but actually block group. I guess it's the census tract with the highest employment density to the centroid of the block group. in meters. So I measure downtown distance where the downtown is the highest employment density tract in the city. We'll run this regression model with and without day fixed effects. The dependent variable is average trip generations in the block group per day. So with and without day fixed effects, which actually doesn't much change the sign or significance of the other variables at all, but conceptually could have to control both for seasonality, which we know is occurring, and actually anything else, rainstorm that day, or anything else that might have been happening on that day.
So just to be clear, day fixed effects meaning 365 day fixed effects.
Yeah, dummy variable for every day. Yeah, exactly. We literally put in a dummy variable for every day because the observations are block group days in that model, so we could do that. So, yeah, in other words, it's not an average. I misspoke. It's not an average number of trips per block group. It's literally the number of trips in the block group in that day. So we are literally putting in a dummy variable for each day. With a weekend dummy variable interacted with all the right-hand side variables and without. That's the second way we run the model, with and without the weekend interaction. And I'll show you results with. And then with an hour of day and weekend interaction. And so it's those last two models that I really want you to keep an eye on.
One more question. Sorry.
Yeah.
But you didn't run a model that had dummy variables for Monday, Tuesday, Wednesday, et cetera.
We looked into that early on, kind of a day of week dummy variable model. And it didn't look like there was any benefit to that over weekday, weekend. We have so many observations that those things could click in significantly Monday versus Tuesday versus Wednesday. It just looked like collapsing it into weekend, weekday gave us as much understanding as far as we could tell. It's the weekday, weekend break that seemed to be pretty big. And we played around a little bit with, does weekend include Friday night, not include Sunday night? Since we actually have hourly data. We ended up landing on calling the weekend all of Saturday and Sunday looked to be as good as any other option. And so, which is a little surprising, right? Because logically you think Friday night would behave more like a weekend than Sunday night. In the regression, that didn't pop out. So now before I get into the regression results, we have an issue here that we've tried to resolve and have not completely resolved yet. And that is that we have lots of zeros in the data. So we know that ordinary least squares is not going to be the best option. We've played around with several specifications to handle zeros, and I will show you zero inflated negative binomial regressions, because the issue is that we have so many zeros that the zero inflated part of that zero inflated negative binomial may indeed be important. Zero inflated negative binomial regression is basically a two-step approach, where to use this kind of loosely speaking, you're first of all running a regression to predict whether or not you have a zero or a non-zero, and then conditional on what you find in that first stage, how many trip counts would you get if you had any non-zero number? Because it's a two-stage, both being nonlinear, interpreting magnitudes off of the second stage, which I'm about to show you, is very difficult. You can do sign and significance. You can't understand much about magnitude. We are continuing to run experiments of what if we varied the independent variables? How would we understand the magnitude? When we get to that, I'm going to revert back to OLS. Not because it's preferred, but because we have yet to get our zero inflated negative binomial regressions to converge with the magnitude experiments because of the number of observations. It's a problem we think we can solve, but we haven't solved yet. So like I said, we're midway. Let me show you. Yes. Mm-hmm.
Was there any consideration to include a variable for the density of age groups? Because
The density of what?
age groups, like thinking that maybe younger people would use scooters more, so,
Ages?
yeah.
Yeah, people have done that. We made a couple of regression design decisions. First of all, we wanted to look strictly at physical land use, not demographics. In this mode, we were thinking we were gonna try to fit the model on these two cities and then predict into California. We could have done that with demographics. We wanted to start simply with land use. So partly because we want to look simply at the built environment. I'm not saying that age doesn't matter, but I classify that as conceptually a different kind of thing. The other thing we did, we had a very strong preference to use only data that could be easily obtained from public data sources anywhere in the country. Meaning we did not want to use local knowledge heavily, knowing we were going to try to predict out of sample into a different area. If we did things like said, we know that there's a district in Minneapolis that has a lot of pedestrian activity, and we'll draw it on a map and put in a dummy variable. That raises the question, how do we identify the same thing consistently and easily in California? So that second design decision was maybe better grounded. We said, we're going to use OpenStreetMap, we're going to use census data sources, we're going to use nothing else. And that did raise an issue. There are variables that we are leaving out due to that. But we also didn't leave out anything about the demographics of the area. So it's a partial model. This is the second stage of the zero inflated negative binomial in columns compared with ordinary least squares, which interestingly, OLS would not be preferred for these data sources. But in terms of signs and significance, there are some variables for which, at least at the sign and significance level, and we can't make a statement about magnitude here, but at least at sign and significance level, going from OLS to ZIMB does not change the hypothesis test, at least. And what you've got here are lined up without the weekend interaction, OLS and ZIMB, with the weekend interaction, OLS and ZIMB, with the trips per day, and then with the trips per day dropping in date fixed effects in the right half of the panel. There's more numbers here that I want you to try to look at. I'll move this. I'm going to try to do, well, I'll talk through it. My image is actually overriding the key right now. I'll show you Minneapolis right now. I don't think I have Louisville on here, but we have a similar pattern. The variables that do have differences across OLS and ZIMB, light yellow highlight means that there's a change in significance, but not a change in sign. The kind of darkish, maybe orange to tan, is a change in sign. And so the density of school buildings is not a robust variable across these specifications. The density of places of worship is not a robust variable across these places. And then I think we'd have a little bit of concern about the robustness of the interaction of downtown distance with weekend. So we'll remember those in a minute. Yeah, so I'll flag those. The reason I'm going to flag those, I want to show you trying to figure out magnitudes, which we could not currently do with the ZIMB model. We're still working on that. Trying to infer magnitudes. One thing to remember from this, looking at these coefficients, from the OLS, yes, you could infer a magnitude. From the ZIMB, you can't really infer a magnitude from the coefficient. And the magnitude would be interesting. So what I'm going to do is to revert back to the OLS model, now with day fixed effects. By the way, the difference in sign significance across with and without day fixed effects, I don't think we found any change in hypothesis test. So with and without day fixed effects at the hypothesis testing level, we're not worried about. I know what I'm doing here. I'm using robustness tests for hypothesis and then making arguments for magnitudes. If you did this in a class, we'd grade you down. Be that as it may. Okay, moving forward. What we did from the OLS model because it was computationally feasible, is we started every independent variable at the median value for the sample. This is Louisville right now. We'll show you the same thing in a minute for Minneapolis. And we added an increment. And an increment that was picked to be something that was a round number that made sense, that you could imagine what it means. So we start you at the median and we add 1,000 jobs per square mile and 1,000 people per square mile to the block group. And we ask from the predicted values, what would be the change, holding every other variable constant on the right-hand side, changing only one variable at a time? What would be the change in trips per day from adding that increment? And what I'm showing you on the right-hand side is once we drop in those 1,000 jobs per square mile or the 1,000 people per square mile, we started you at the median of that samples distribution for that variable. Where does that land you in the percentile distribution? Meaning if I start at the median of job density and I add 1,000 jobs per square mile, I have now moved you to the 86.5th percentile of the distribution. So these were numbers that were chosen to be somewhat meaningful, like for example, 1 restaurant, 1 bar, 1 school, 1 university building, 5,000 meters from the central business district as an example. But they're all moving you from the median for that variable to approximately the 75th to the 95th percentile. High into the distribution, not ridiculously, absolutely crazy high. That's what we were aiming for. Moving from median to high into the sample distribution for that city. And having things that we would judge would be similar movements. And I want to focus you on what happens then for these similar movements in independent variables to changing the increment in predicted trips per day. Now remember, these are all moving one variable at a time. So literally on a weekday, if you add 1,000 jobs to a block to the block group, starting from a value that is a median value. So we're just generating 2 predicted values from the regression. The change in trips per day is 4.292. And this is a way to understand, in effect, a marginal effect of each variable.
Question. If I recall, the average trip per day in Louisville was 1.6.
Yeah, I think that's about right.
Okay.
Yeah.
So you are increasing density by a factor of 5.
So
Right.
we are. And that's the median value, but the mean's probably close to it. Yeah.
Yeah, and so of course you're gonna end up near the end of the distribution.
Yeah.
And it looks like you're gonna get, about that magnitude of an increase in trips.
Ballpark, maybe. It's quite possible that if you ask which of these variables are elastic and which are inelastic, which you can kind of back out, none of them might be elastic. Maybe job density once you come in on weekend, because that weekend is additive to the weekday. So one way to think about that, if we increased the job density by 1,000 jobs, on a weekend, you're getting about 10.6 additional trips. So at that point, on the weekend, that's an elastic effect.
Yeah, that's very elastic.
Yeah. Yeah, so part of it, the magnitudes are big because the changes in the independent variables are big. And that's what we were kind of aiming for, is what would a big change in a dependent variable? But we were pegging big to within the distribution of what you see in the city. But it's a big change. Moving a block group from a median employment to 86th percentile distribution is a pretty big deal. Something that reasonably you could say, hey, you'd never really do this. I grant that. So, Katrina?
I have a question from Anastasia Stasiakos.
Yep.
One would assume that the price users pay to operate a scooter would affect the number of trips. Did you have a chance to correlate trip data with pricing policies?
No, we were not able to do that. No. So not that it it would be a good thing to look at. We just don't know. We were only looking at land use. So that's a fair point, yeah. What I want to do is to use these to kind of give you a feel for what are the land use characteristics that look like they bring the biggest impact. And I highlighted in blue the variables that are positively associated with trip generation and have the highest marginal impact. And it looks like job density and bar club. And notice how, for example, those are noticeably bigger than anything we're getting on density food. We think bar club is proxying a lot, by the way. We think that's proxying likely activity and entertainment districts, and it's probably doing that in a way that is better than food establishments. And I don't have a strong argument for why, but we think it's a proxy effect, that it's not the bar itself, but that there's a lot that goes with bars and clubs in terms of districts that are also conducive somehow to places where people take dockless trips. In Louisville, surprisingly, the density of university buildings is negatively associated with trip generations, counter to our expectation, counter to what you're going to see in Minneapolis. So we don't have a good explanation for that, except we think there's something about where the university is located in Louisville that will likely explain that. And it's, yeah, Sam.
We have a question from Jacob Ritchie. Thanks for speaking today. How did you decide the OSM variables and how did you clean the data? I know some OSM variables aren't the most reliable.
we picked the OSM variables to be the land uses we thought might relate. In terms of cleaning the data, I'll let Clemens field this. He cleaned the OSM data, but I think we mostly took the OSM data as truth. Clemens, that's basically what we did.
So, I mean, the issue is there aren't really any good sources for all points of restaurants or all points of bars. OSM is actually as close to a consistent measurement you'll get for the entire planet as exists out there. What we did was we got the point locations of all of these features. So one bar is 1 point. We then identify which census block group any given bar or food establishment or any of these falls into, and then simply count how many points fall into any given block group and divide that by the area to get the densities included in them all.
Yeah. So to kind of repeat that, because I don't know how well we're set up to carry that out to Zoom. So let me repeat that. The question was really about the reliability of OSM data, which is crowdsourced, basically. So it may not be reliable. We took it as truth. I'm going to say it even a little bit that firmly. So it may or may not be reliable. We're relying on the crowdsourcing. I will tell you, in some of the places in California where we had local knowledge, we didn't see anything about the OSM data that looked obviously wrong. We just simply took it as truth. It's a data source. One thing to remember is that if we didn't use OSM data, we're in a world of going to MPOs and asking for their land use data, and that's even more difficult. We took it as truth. It might be awful. There you have it. We don't think it's awful, by the way, but it is certainly crowdsourced. Downtown distance, you get further away from the downtown, you have fewer dockless trips. Let me go to Minneapolis, because we're actually going to use the Minneapolis model to do some out of sample prediction into California. And we did that in large part because Minneapolis is a larger city that we thought may have more similarities just in terms of size of the metro area to the metro areas within California that we were predicting into. Louisville's a much smaller city. Same exercise, moving from median to a increment value on every independent variable. Now the increment values vary because the same story. We're trying to land you approximately around the 75th to 95th percentile in the distribution, except for now one food establishment moves you into only the 54th percentile of the distribution. So it may not be a great apples to apples comparison there. But for all of these increments from the OLS model, how do the number of trips per day change, and I don't know why that just happened. Try this, okay. Okay, so the impacts that in terms of magnitude look large have a lot of similarity to Louisville. If you ask, what are the variables that seem to really kick in an OLS with meaningful magnitude? Job density, bar club, university buildings are now figuring in positively, not negatively. And then there's a damping effect. You get further from the downtown, you have fewer trip generations while controlling for these other factors. We did have real variation across OLS and ZIMB in terms of school, in terms of places of worship. Those are never kicking in with meaningful magnitudes and prediction. It's not a guarantee because this is off of OLS and there could be something with ZIMB that said, oh, the magnitude got really big. But this is some point of assurance that if we're about to predict with OLS, which we're about to do, then at least the variables that matter, at least in OLS, were the drivers of the magnitude or predicted value. So let me do one thing real quick. There's definitely weekend variation. A lot of these variables will give you as much of an additional effect in terms of trip generation on the weekend as they are giving you on the weekday. And that's not a change in the constant, that's a change in the interaction variable. So job density and bar club, when you look at that weekday magnitude in terms of predicted trips, on the weekend, what is highlighted in blue is an additional increment from those land uses on the weekend. So they are doing more for trip generation, those land use characteristics on the weekend. Let me pick up the pace because I wanted to wrap by one, and I think I'm going too slow. So let me summarize, and I'm just gonna, I've said a lot of this, so I may have to just, move past this quickly. We are getting generally larger marginal effects on weekends. If you look at the right-hand side of this, from job density, from bar club density, from university building density in Minneapolis only, and from downtown proximity. So it's not just that those variables matter, but all those variables in the Minneapolis model matter more on the weekend, which is leading to clearly everything I've shown you is consistent with scooters being associated with entertainment districts in some ways, activity centers that are in part correlated with job centers and downtown, but it looks like they are not simply job centers or downtown. Scooters are an unusual travel mode. We're starting to learn that. They don't look like other travel modes. They seem to have a strong correlation with these leisure entertainment activity districts. And that's the type of travel. And so, your intuition is kind of borne out by this model that, the model and the descriptive statistics are behaving this way. We do the same kind of weekday weekend model, now OLS only, with hour of the day interaction variables. And then we'll plot the marginal effects from those interaction variables. And if you look at these plots where the mean effect is the solid horizontal line, and where you're above the mean, that's where you're getting a larger effect. Take a look at, for example, job density, where the blue is the weekday and the red is the weekend. Job density has an effect on trip generation that is larger in the afternoons and early evenings. And that effect is stronger on the weekday than on the weekend. Population density, which is kind of, I'm going to argue, generally uninteresting, actually has the counter effect. Afternoon and weekend, it has a smaller effect. Bar club, definitely an afternoon evening phenomenon, kicking in what appears to be a little bit later in the day, but a lot of this is kind of approximately 2 to 3 p.m. to later, and a larger effect on the weekend. And this is the Minneapolis model. The university buildings are also afternoon, evening. The downtown proximity effect is larger in the morning. So there's real time of day variation, all of which, again, consistent with almost this being an activity, a mode that you would use in activity and entertainment districts. This all kind of seems to paint that same picture. Let me do the last thing quickly. What about places with no data? We'd love to just access the data. They're sitting in servers in Los Angeles right now to look at this question. It's not possible, and I think we may have to begin to prepare for the possibility that it may never be possible. If you were to ask me, I would say we have all kinds of ways that we can protect user anonymity and user confidentiality, all kinds of ways. It's not for me to decide. It's for elected officials to decide, and they seem to be coming down on with a different answer, being overly cautious about confidentiality. So what would happen if we use the Minneapolis model to predict trip generations? Well, first of all, we did do a test with a place where we could compare predicted to actual data, and that was Austin. We used the Minneapolis model to get census tract level trip generations in Austin. And then we asked, how often did the Minneapolis model predict that a tract would be in the top 75th percentile of predicted trip generations, and compare that to how often did they get that top 75th percentile prediction correct. In other words, we knew the actual data for Austin, what tracts were in the 75th percentile or above, really the top 25% of actual. And then the model from Minneapolis, how correctly is it identifying those top 25% of trip generating tracts? And it's doing that about 60% of the time. So in an ordinal sense, there's what you might judge to be okay-ish out of sample predictive power. And we're thinking ordinally now, not magnitude, just what are the places that have more trip generations? So now we're going to take this into California. Let me show you some maps. Minneapolis model predicting trip generations in block groups in the Los Angeles region, where we divide the predicted number of trips per block group into 30 categories. And we are showing you the 4 highest categories, 27th, 28th, 29th, and 30th highest. This is why we wanted to focus ordinally. There's lots and lots of zeros. There's lots and lots of predicted zeros. So only if you take kind of these top 4 of the 30 groupings is where things get interesting and you have some predicted trips. The places that you see light up here, in part, maybe don't look crazy, and in part might. The Wilshire corridor going all the way out to Santa Monica lights up, and that may not be crazy. We get Venice Beach coming in. We get what looks like Marina Del Rey. We get some areas that might be Culver City-ish. We get a lot of downtown, including some East LA, but also large portions of downtown where you might be a little surprised if you saw some dockless trips. Looks like UCLA is lighting up. Portions of the South Bay, including places that I think probably don't make sense. So I want you to flag this. It's a pattern that probably includes places where indeed there might be dockless trips and places where there may not. Let me go to Orange County and talk this through a little bit. Orange County, look at the places that are lighting up. Newport Beach, not bad. Little bit of Huntington Beach, not bad. Huge swaths of area in what's called the Irvine Business Complex. Probably a big problem or an incorrect prediction. The Irvine Business Complex is not a place where you are going to see lots of dockless trips showing up. The variables that are going to predict dockless trips are job density, bar club density, university buildings, distance from downtown. Job density could easily misfire, particularly in suburban locations. And we think that's a big part of what's happening here in the Irvine Business Complex. Any suburban office location in this model, we're going to say, oh, you're going to have a lot of predicted dockless trips. And suburban office parks may be bad places for dockless trips. So there's a combination of what appears to at a first visual glance be maybe some validity and maybe some serious misfiring. Let me keep going on this and I'll tell you where we land. San Francisco and Oakland. Downtown, market area, Pier, south of Market, not bad locations. It's figuring in strongly, and there's probably locations there that may be amenable to dockless and locations that may not. And by the way, we have no slope in the model. And for San Francisco, you might think, hey, would slope matter? And I would think yes, but I'm not a dockless rider myself, so who knows? The East Bay, over here, I'm a little bit suspicious of this concentration, which may be industrial. Places near Berkeley appear to light up, and that makes a little bit of sense. The same kind of pattern. Job density may be helping and might be messing us up in terms of the predicted pattern, and both of those might be occurring. Last map, because remember, the way we built the model, we can actually generate these maps anywhere. We have to pause to figure out what we think of them, but they're easy to generate now. And so San Diego, Mission Bay, that might be a dockless kind of place. I don't know, maybe this is near UC San Diego and a little bit of La Jolla, maybe some downtown locations. Claremont Mesa, I don't know about that. That does not make sense. That's probably a lot of industrial jobs without a lot of dockless friendly actual land uses. So it looks like, again, some real misfiring, maybe with some meaning. Where we landed on this is that if you were a planner, we would suggest this as an initial screen to which you had to bring local knowledge, because clearly something like this, might be, we said maybe as an initial screen, if you knew nothing else, if you were wondering what are the places that might be amenable to dockless travel, here's a first screen, then you literally have to bring local knowledge, walk the neighborhoods, get more information, and literally take out the places where there were predicted dockless locations that made no sense. So we propose this as maybe an initial screen. I think this is absolutely everything that I've got. And so where we landed, there's clear time of day and hour of day variation in the land use correlates. And what it tells us is that the dockless mode is an unusual mode that is heavily associated with entertainment land uses in ways that are not like other modes. Can you predict out of sample? Not something that would be ideal, but you might be able to get at least to an initial screen if a planner were going to carefully combine that with local knowledge. Let me pause. Any questions? So let's go, I guess, first to Robert and then to Katrina.
Yeah, this might be, this is obviously a separate study, but I was wondering if you guys early on gave any consideration to the actual company policies of when they switch where those scooters are going to be and how that might affect like how someone thinks how reliable it is for me to use this as a transportation form itself.
We tried some, and by the way, referees are just on fire on this point.
Okay.
And so, in terms of where is the dockless, where are the scooters supplied?
Right.
We think that's an endogenous variable, that it isn't that's actually exogenous, that they're repositioning and supplying or regulated to supply the scooters in some cases based on things like land use characteristics. So we were a little bit unsure how to bring that in. We think it might be a two-step model. It's not in there now, and it's clearly missing. And so but a little bit of we didn't quite know. We think it's more complicated than just kind of bringing in supply of scooters.
Yeah, I'm guessing every company has their own policy anyways.
By the way, the state of the art is just bring in supply of scooters. We just weren't happy with that as the way to measure that, but we think we've got to bring that in somehow. Katrina?
We have a question from Niwa Mitsuo. It's regarding the slide with the summary. She said, it's interesting to have opposite signs for university buildings for two cities. Do you have any thoughts about that?
Our best thought, and it's not a great thought, is that there's something about where the University of Louisville is, and possibly something about the local policy, but we never uncovered anything odd about the local policy. Sometimes universities will take some steps to restrict dockless travel. There might be something going on there that we didn't uncover.
I have two questions.
Mhm.
about method, basically. The first question is, what would be, what would be the possibility of splitting up the estimation, given the zero problem? And have one model that actually predicts a trip or not. And then have an OLS model that includes only those that made the trip. So, so that's question number one. Question number two, in terms of the predictive stuff, did you think about holding out? You have such a large sample, holding out part of the sample so that you could estimate the model and then use the held out sample to test how well you're predicting on the actual data. So that you would get
Yeah.
some sense of, well, I'm within 10%. And then you go to Austin and you try Austin. And then you have something
Yeah.
like the incremental effect of going out of sample.
Yeah. I think we tried that, but not as well as you suggested. Clemens, didn't we try how well we tried? We tried how well Minneapolis predicted into Louisville and vice versa.
Yeah, we did that.
I don't think we did a holdout in the way you're suggesting. It's a great idea.
We didn't do a holdout, and part of the issue is that our observations are block groups. And if you randomly, I guess you could randomly.
We
choose
still
block
had to
groups
do
you want.
randomly pull part of the sample, yeah.
We might be able to hold out block group days, I'm thinking.
Yeah, we're not doing much with the variation across.
Because you've
days,
got-
but
you've got- With Minneapolis, you've got 1 million, right?
It's
A million trips. Our observations end up being number of block groups times number of days.
Oh, how many
So
block group? Well, what's your number of observations?
let's see. Hold on.
I didn't manage to look at.
In Minneapolis, we're in the 140,000 range. We could, I think we could do something like that. I think, I like that idea a lot. And I think, Clemens, we're discussing this at 3 p.m. today, right?
We are.
Very timely suggestion, so I like that a lot. And on the, could we basically do like a logit and then OLS? I might take a look. I haven't thought about that. What we're trying now is to see if we can simplify the model to get the marginal effect to converge with the CIMB, which might be better. So yeah, I mean, I might try that. What we need is something to simplify that can handle the sensory.
You can take a page out of our colleagues in engineering's book. And is this a machine learning problem?
Let me give this some thought.
You don't have a whole lot of variables here, but anyway,
You know what?
enough from me.
Yeah, send me a name of is people who are good at machine learning. Is it
You
so-
gang.
Cyrus and
You gang.
you gang? That would be interesting to come at that a different way. Yeah,
Because it's one of these things almost where, and I won't go on for much longer, I promise. It's one of these things where you're interested in the land use effects, but you're also interested in predicting. The machine learning people are all about predicting.
yeah,
And so they would throw
yes,
the
everything.
entire kettle of soup into
know-
the model.
I like that idea.
Maybe, given that you want to predict, why not use some of these other variables that are not?
There- I like everything about this, but the machine learning thing, those are basically, as I understand them, variance minimization machines. That's the way I speak of them as, which means, and if you're trying to predict, that's not a bad idea.
But they are, their whole deal is predicting.
Yeah. No, so thank you. These are excellent suggestions. So thank you. Katrina?
We've got a question from Dylan Fitch. I'm curious about your statements about misfirings. Example, predictions in Irvine's business district, San Diego's Mission Valley may be poor. I've been thinking a lot recently about how micro-mobility services could combat worker midday car travel in these exact types of places. Couldn't it work just different from the micro-mobility services we see in large urban cities? Thoughts?
In concept, yes. Katrina, in concept, the question was, for example, in Orange County, I said that the Irvine Business Complex, the prediction model misfired. It predicted a lot of dockless trips. It's a suburban office complex. It's not conducive to dockless trips. And the question was, I'll rephrase it, but if we readapted the built environment to be more friendly to non-car travel, could that be conducive to dockless trips? And I would say, yes, it could, but that's a much different question now. In other words, we're saying, what if we went in and changed the whole built environment? And the answer is yes, but trying to stay at least closer to the data. Remember, this is an unusual mode. 2 wheels, younger people will like it, older people won't. Cars driving by at 50 miles an hour on the street, as they do in the Irvine Business Complex, could be deeply worrying to people on a 2-wheel device. So right now, given this mode, the Irvine Business Complex would just be an awful place for it. You could retrofit that place for a different kind of non-car mode later, but I think that's going beyond the data and analysis, but it is a point that's an important point. So, yeah.
Any others from our Zoom population?
No, that's
It? Okay.
Right.
Well, we say thank you very much